All right, we are going to look at the numerical concept as our topic, and we shall look at the details of the content throughout the whole topic. Right on the screen, you can able see that the title, numerical concepts, the illustrations 0, 1, 2, which means we shall be dealing with the numbers as you can see displayed there. We shall look at multiplication, we shall look at the addition, there is the subtraction, there is the division, and in every other numbers we shall add, do all of the operations. So from there, we now ask ourselves, what are numbers? Numbers are mathematical concepts used to count, measure, and label quantities. They are represented by symbols called numerals, like 5, can be 2, 3, or any other, and are fundamental to mathematics, allowing us to perform calculations and express values. Numbers are also used for ordering, identification, and coding, and the concept has evolved to include different types such as whole numbers, natural numbers, integers, rational numbers, irrational numbers, and real numbers. So now we can look at types of numbers.
Hello and welcome to My Secret Math Tutor. For this video I want to talk about the different types of numbers that you'll see working through some of our basic math videos. So the first type of numbers that you're usually exposed to are the natural numbers, or what we sometimes call the counting numbers. These are the familiar numbers of 1, 2, 3, 4, 5, and really they just keep going after that. They're called your counting numbers because they're the ones you usually start counting with, such as, I have 1 car, 2 car, 3 cars, all the way up the line. When you see a notation like this, those little dots after the end, that means it keeps going. So this list is much longer than what I've made it here, but it gives you an idea of the first few numbers in the natural numbers. Now, as we get to the whole numbers, you'll notice that it contains a lot of the same numbers, but we also include 0 in that category. So I can say that 0, 1, 2, 3, 4, 5, and of course these keep going as well. All of these are types of whole numbers. Now, don't worry that I actually have listed out the same number twice. I'll get to that in just a little bit. Let's go ahead and see the next group of numbers. The next major group of numbers, those are our integers. And they contain not only the familiar counting numbers, 0, but they also contain the negatives of the counting numbers. So you'll see stuff like -1, -2, -3, -4, and all the way down the line this way, much further into like -5, -6, all the way down, as far as you can go. So one thing that you've probably seen is that I've shown you 3 groups right now, the natural numbers, and we've seen the integers, and we've seen the whole numbers, but I've listed out the same number more than once in some of these groups. One thing that you want to keep in mind as you're learning about these new groups is that a number can be in more than one group. It's completely okay. So for example, let's take the number 5 here. We've already seen 3 different groups, and it turns out that 5 is in all of those groups. So you want to know that you can call 5 a type of natural number. You can also call it a whole number. And of course, you can call it one of our integers. 5 is in all of those categories. Now, some numbers are only in a few categories, so you want to make sure that you are familiar with those groups. So for example, if I get over to 0 here, 0 is not one of our natural numbers. It is a whole number, and of course, it is one of our integers. Now, these numbers are actually in many more groups, which we'll see in just a little bit, but for now, notice how you can take them and really put them in more than one group. So far, if I'm looking at a number like -2, right now it's only in my integer group. And I'll talk more about how you can classify these numbers in another video. So let's continue on learning about some more groups that we can classify numbers. The next really big group of numbers is our rational numbers. Now, these are any number that can be written as a fraction, so it makes it a little bit more difficult to try and list these out. But one thing you want to recognize is that if it's already a fraction, of course I can write it as a fraction, so it would be counted as a type of rational number. So these guys both contain fractions. Yes, they are rational. It also includes those groups we saw before, like integers, natural numbers, and whole numbers, because all of these can also be written as a fraction simply by putting them over 1. Don't let things like radicals or other types of decimals fool you. Those might also be rational numbers, especially if you can take that radical, simplify it, and it turns into an earlier group like a natural number, which of course can be written as a fraction as well. A lot of decimals that stop can also be written as a nice rational value, and that's simply by taking the number and putting it over whatever decimal place it terminates at. So something like 2.8 can really be written as 28 tenths, so since I can write it as a fraction, it is a type of rational number. Numbers that go on forever and ever might be a rational number as long as they repeat themselves along the way. So something like 0.33333 repeating is actually just the fraction 1/3. And since I can write that one as a fraction, of course it gets to be a rational number. So be on the watch out for any type of number that you can write as a fraction so that you know it goes into the rational numbers group. All right, the next major group, the irrational numbers. You almost want to consider these like the opposite of our rational numbers. These are numbers that cannot be written as a fraction. So as hard as we try, their decimal just keeps on going forever and ever, and it doesn't repeat. You'll see numbers in this category like the square root of 3. That one I can't write as a fraction. Or numbers like pi. Again, that one, it has a decimal that goes on forever and ever, and it doesn't ever repeat, so there's no way I can end up writing it as a fraction. These are usually really easy to identify if you are given a decimal. That way you can inspect it and say, okay, yes, I can see that this decimal keeps on going, and moreover that I don't see any repetition in there. Take note that even if this has a little bit that does repeat, like the 6s that repeat, what I'm really looking for is, do I have a whole string of numbers that end up repeating? That's really what put it in the rational bin. So unfortunately, even though it does have a couple of 6s repeating in here, it's still not enough to say that this is a rational number. That's why I'm putting it in the irrational group. All right, one more group of numbers, and those are our real numbers. The real numbers really include all of the rational and the irrational numbers. And so they really make up the majority of the numbers you'll see working through some of the basic math videos. So all of our first few groups, like the natural numbers and the whole numbers, those fall into the category of also being real numbers. So you'll see I have things like 2, -3, 0, all of those considered real numbers. Now, since it contains the rational numbers, you'll also see numbers that can be written as a fraction. Stuff like 4/7, 5 1/3, 2.7. Since all of these can be written as a fraction, those are rational, and the real numbers contain all of the rationals, so that's why they're in the group. And lastly, it contains all of our irrational numbers. So things like the square root of 5 or pi, yep, those are also considered real numbers. So you can see we have a variety of different groups here that you can really take a number and classify it in. Remember that as you're working through these, that a number really can be in more than one group. So now that you know a few more groups, we can actually even expand on these ones and say, not only is 5 a natural number and an integer and a whole number, I can also call it a rational number since it can be written as a fraction, and it is a type of real number. So always be on the lookout as you're learning new types of numbers to think about the numbers you've already learned about and what groups that those would end up being in. In my next video, we'll talk about how you can take these numbers and classify them a little bit better, and also how these different types fit into one another. If you'd like to see some more videos, please visit mysecretmathtutor.com.
So now we can proceed and look at other numbers like even numbers, odd numbers, prime numbers, and composite numbers. In summary, odd numbers are numbers that end in 1, can end in 3, 5, 7, or 9. You can give an example. So long as you end with any of the digits mentioned, then you have written down an odd number. Next, we have even numbers. Even numbers, as you can see here. Even numbers are the numbers that end in 0, can end in 2, in 4, in 6, or in 8. So any number that you write ending with any of the digits is an even number. And you need to note that the first or the lowest even number we can talk about here is a 2. Some learners tend to use a 0, but 0 is not correct. We consider the first digit as 2 in the natural numbers. Next, we have prime numbers. Prime numbers, these are numbers that have two factors, 1 and itself. Examples can be like 2, can be 3, can be 5, 7, can be 11, 13, or any other that you can mention, so long as you can mention up to only 2 factors, and the being 1 and the number itself, then you have a prime number. Lastly, we look at composite numbers in the last part. Composite numbers, these are numbers that have more than 2 factors. So 1, we have seen prime numbers. Now the first 2 factors will be 1 and itself, then there must be the other factor or factors. So any number that has more than 2 factors will be regarded to be a composite number. So we now go to something else. In another slide, we look at directed numbers. Directed numbers are numbers that have both size or magnitude and direction, usually represented by a positive or a negative sign. They are used to show movement, position, or change in opposite directions from a reference point. There must be a reference point, often called 0. We normally refer from 0, and that's how we end up attaching a positive or negative depending on the direction that you are taking from 0. Examples are listed in the table below. One of the real life situations is like when we are reading the temperatures on thermometer or recording the temperature of the surrounding. If let's say the temperature is above 0 degrees Celsius, we say 5 degrees Celsius, we record that one to be positive. But if the temperature is below 0 degrees Celsius, we say it is 3 degrees Celsius, but we put a negative to show that it is below 0. So that's what we meant by reference point as 0. Then if we go to another situation where you are measuring like height, when the height is above sea level, we say it is positive 200 meters above sea level. That is in reference to 0. And if it is below sea level, then we say it is, let's say 50 meters below sea level, we say it is negative 50 meters. We also have the same concept of negative and positive in money. For instance, if someone is talking about profit or income made, if someone has made a profit, then that money, if let's say it's a profit of 5,000 shillings, then we say this person has an income of positive UGX 5,000. But if someone incurs a loss or it is a debt of 5,000 shillings, then we record it as a negative of 5,000 shillings to this person. We also have another situation for direction. Directions are given also in reference to a certain direction and reference to a certain point. For instance, from 0, if someone moves due east, 5 meters due east, say that is positive 5 meters. But if someone covers 5 meters due west, we say that is negative 5 meters. So that's how directed numbers help us in showing movement, position, and anything like changes in the directions. We now go deep into addition and subtraction with integers. To add and subtract integers, we use rules. With the same signs, you add the absolute values and keep the sign with different signs. Subtract the smaller absolute value from the larger one and keep the sign of the number with the larger absolute values. For subtraction, write the problem as addition by adding the opposite of the numbers being subtracted, e.g. a minus negative b becomes a plus b. We have examples here. If you have a positive plus a positive, the answer will be positive. Like if you have 4 plus 8, it gives you 12. All the numbers are positive. And if you have a negative number, a negative value plus a negative value, it gives you a negative result. As you can see in the example, negative 6 plus negative 3 takes you to negative 9. If you have a positive plus a negative, depending on the one which is big, use the sign of the larger absolute value number. So for instance, 12 plus negative 7 will give us positive 5. But if we have 10 plus negative 14, it becomes a negative 4. So we use the sign. If the sign is of the bigger number or of the larger number is negative, then we do subtraction. If the sign of the bigger number is positive, then we do get a positive. If the bigger number is negative, we do get a negative. Then when you get a negative plus a positive, it is the same thing, only that we have reversed. Still, the bigger number takes the sign. Here, negative 13 plus positive 16. The larger number is 16, so we shall get a positive. Negative plus positive 7, you get negative 2 because the bigger number is negative. So once you are adding or subtracting, you keep noting the number. The sign on the bigger number will determine the result. Then we go to multiplication and division of integers. The multiplication and division of integers have the same rules. If the signs are the same, the result is positive. Here it means if the signs are positive, or you are multiplying a negative, the answer will always be positive. And if the signs are different, the result is negative. For example, multiplying two negative integers results in a positive number. Let's say negative 5 times negative 2 gives us positive 10. While multiplying a positive and a negative results in a negative number. An example is 5 times negative 2, which gives a negative 10. So long as the signs are different, then we shall always get a negative answer. That's why we are getting a negative 10 here. The same logic applies to division. Same signs yield a positive quotient. Different signs yield a negative quotient. We can understand that one further by looking at the slides and the pictures displayed here. For some multiplication is here, positive and positive, you get a positive, negative and negative, you get a positive because they are, in each case, they are same signs. Then positive and negative, then negative and positive, each will give a negative because we are multiplying different signs. The same applies to division. When you are dividing positive by positive or negative by negative, the answer will be a positive because you are using same signs. But if you do division with the different signs, the answer will always be negative. So that table can always help you to remember the signs of the numbers that you get whenever you multiply or add. So lastly, we shall look at factors and multiples. In multiplication, when two or more numbers are multiplied together, the product or answer obtained is called a multiple of the numbers. The numbers multiplied together are called the factors. Example, in part A, if 2 times 3 is equal to 6, then 6 is a multiple of 2 and 3, and therefore 2 and 3 are some of the factors of 6. In another example, if 3 times 7 times 4 is 84, 3, 7, and 4 are some of the factors of 84, but 84 is a multiple of 3, 4, and 7. Let us follow this video to see this one further, where we shall determine the highest common factor and even a lowest common multiple for numbers.
Hey everyone, I am Lara.
And I am Lorenzo.
Today we will be diving deep into the world of highest common factors
And lowest common multiples.
Do you remember that a factor is a whole number that divides another whole number exactly, leaving no remainder? For example, the factors of 12 are 1, 2, 3, 4, 6, and 12, because these numbers divide 12 exactly without leaving a remainder. This is why highest common factors are also called greatest common divisors.
With multiples, we do the opposite. Multiples are basically the answers in any set of times tables. Look at the multiples of 3 and 8. All you are doing is skip counting by 8 and 3.
Lorenzo, did you see that 24 is a multiple of both 8 and 3 because 8 multiplied by 3 equals 24? This is cool because we can see that factors are the numbers you times together to get the multiple. We can then also say that 8 and 3 are 24's factors, along with 1, 2, 4, 6, and 12.
That's right. Now that we have covered the basics, it's time to put it all together.
First, let's take a look at highest common factors. To give you a practical example, imagine you're planning a party and you want to make sure all your friends get an equal number of popping candy. Finding the highest common factor helps us find the largest number of popping candy that can be given out equally among all your friends. So here's how to work it out. Let's use the numbers 16 and 24. Step 1. List all the factors of each number. 16 has the factors 1, 2, 4, 8, 16, and 24 has the factors 1, 2, 3, 4, 6, 8, 12, 24. Step 2. Identify the highest factor that is found in both lists. We can see that the factor 1 is in both lists, so is 2 and 4 and 8. But out of those, 8 is the highest number, so 8 is the highest common factor. That wasn't too difficult, right? If you need an extra boost, check out our other video about factors. Let's move on to multiples with Lorenzo.
To keep it simple, we are going to find the smallest common multiple for 2 or more numbers. Let's use the same numbers 16 and 24, and this time find the lowest common multiple, or LCM. There are only 3 steps. Step 1. List multiples. Step 2. Find common multiples. Step 3. Choose the smallest multiple. To find the multiples of 16, we start with 16 as the first multiple. Then, we times it by 2 to get the second one. To get the third multiple, we times 16 by 3. We continue this to get a sequence of multiples, basically doing the 16 times table. 16's multiples are 16, 32, 48, 64, etc. Now we can do the same for 24. We'll start off with 24 as the first multiple, then multiply by 2 to get the next multiple, which is 48. To get the third one, we multiply by 3 to get 72 and so on. So 24's multiples are 24, 48, 72, 96, etc. The LCM is the lowest multiple that is found in both lists. We can see the lowest multiple that is common to both lists is 48. So we say that the LCM of 16 and 24 is 48. We can stop the list when we have found the lowest common multiple. Let's take a look at another example together before you have a go yourself. This time with the pair 15 and 25. Let's start by practicing and working out the highest common factor. Here are the factors for 15. And for 25? The largest factor they both share is 5, making 5 our HCF. Now, let's check out their LCM. Here are the multiples for 15 and for 25. The smallest number that is in both lists is 75, making 75 our LCM.
Now it's your turn. Try to find the HCF and LCM for the pair 24 and 36. Pause the video to work it out. That's right, 12 is the HCF as it's the largest factor they both share. And 72 is the LCM as it's the smallest multiple they both share. Thanks for watching.
Remember to like this video and subscribe to help us reach 1 million.
So now we go to divisibility tests. We want to see if we want to find multiples or highest common factors. We want to know which numbers are divisible and which one are not. So in this section, we shall use factors and multiples to determine whether a given number can be divided or factorized. A number is given by 1, 2 if a number is divisible by 2 if the last digit of the number is 0 or is an even number. Remember, we had said 0 is not an even number. That's why we have it as an independent case here. So an example, so long as you end with a 0 or you end with a digit which is an even number, then you have a number divisible by 2. Can take an example of 106 and 50. Number 2, a number is divisible by 3 if the sum of its digits is divisible by 3. So if you add the digits and you find a number which is divisible by 3, then that number is also divisible by 3. Next, a number is divisible by 4 if the last two digits are divisible by 4 or are 0, 0, e.g. 124. As long as the last two digits, because the last two digits 24 are divisible by 4, then the other digits you can attach will make a number divisible by 4. Or in this number, so long as we are ending with 2 zeros, it means we have a number which is divisible by 4. A number is said to be divisible by 5 if the last digit of the number is either a 0 or 5. So an example, so long as you end with a 5 or a 0, you have a number divisible by 5. If the number is divisible by 6, that number is even and is divisible by both 2 and 3. So to be divisible by 6, it must be an even number first of all. It must also be divisible by both 2 and 3. So it must satisfy condition 2, condition 1, and condition 2 for it to be divisible by 6. An example is 96 or 144. Then a number is said to be divisible by 8 if the last three digits of the numbers make a sum divisible by 8. The last three digits. So you look at the number, go the last three digits, add them. If you get an answer which is divisible by 8, that number is also divisible by 8. Also, you can check if the end is in 3 digits, you are sure the number will be divisible by 8. Examples are here. This one end is in 3 zeros, it is divisible. If you add the last three digits here, 2 plus 2 plus 4 is 8, and since 8 is divisible by 8, the whole number, this number will be divisible by 8. A number is said to be divisible by 9 if the sum of all the digits can be divisible by 9. An example is 1, 2, 3, 3. Add all the digits here, you get 9. Since 9 is divisible, this number is also divisible by 9. Check 207. Makes a sum of 9. 9 is divisible, so this number becomes divisible by 9. Then for 10, a number is divisible by 10 if the last digit of the number is 0. That's only the case we have. If a number ends in 0, then it is divisible by 10. Otherwise, it is not. Then for 11, if the sum, a number is divisible by 11 if the sum of the odd position digits and even position digits are equal or differ by a multiple of 11. For instance, this in the odd position for this one, we have 3, and in even position we also have 3. So when they are equal, because here when you get the sum to 3, this one is 3. So because the sum of digits in odd position is equal to the digits in even position, this number will be divisible by 11. Check this one is 11, check this one is 0. So the difference between 11 and 0 is 11, and since 11 is divisible, then we say 506 is divisible by 11. And lastly, a number is said to be divisible by 12 if the number is divisible by both 3 and 4. So for a number to be divisible by 12, it should also satisfy condition in 2 and 3, because it has to be divisible by 3 and 4. Yes, so finally we come to the end of the topic with the further resources that you can use for reading. You can follow any of the links mentioned there, and then you go for further reading. Thank you so much. I remain Chuma Ronald, the teacher on this platform. Thank you so much.